This Zoom session is being brought to you by the Fractal Recursive 12 Star. All right, for today. Oh dear, I guess I have to go over to a module. Section 1.5. Today we'll be doing 1.5 and 1.6. 1.5 is an extra credit thing, so I won't be going over any of the I won't be going over any other problems. 1.6 is about shifting graphs of functions. So here we go. 1.5 starts us on right. Okay, specific functions and their graphs. Okay. All right, the constant function is a graph. It's a horizontal line at height of the constant. Y equals x is a graph that's a diagonal line through the origin. Y equals x squared is this curve, this U-shaped curve called a parabola. It's the same as various things. The orbits of comets around the sun. There's a special point called the focus right about here. And orbits of comets have this shape with the sun at the focus. They also are the shape of the cable on the Golden Gate Bridge. They are parabolas are also, when you turn them upside down, is a graph of a path of an object through the air, falling under free fall. When we were doing face-to-face, I would illustrate this by throwing an eraser across the room. Good times. It's also the graph of the cross-section of a satellite dish or the back of a, the back of a flashlight. This has a parabolic mirror because if you put a light source at the focus, they bounce off the parabola to make parallel beams. And reversing it, in a radio telescope or radio dish, it turns the parallel beams of radio focuses onto the receiver at the focus. Square root of x is the same as the graph of, let's say, this half of the parabola, only flipped through the diagonal. Y equals x cubed has the graph, a kind of N-shaped graph, which comes in from infinity, slows down to a halt for just a second or just an instant, and then zooms off to infinity. This sort of reminds me of how I drive through the toll plaza at Golden Gate Bridge, slowing down to a halt just for a fraction of a second. The cube root of x is the same as a graph of x cubed, only flipped through the diagonal. This and this are like this and this, what are called inverse functions. 1 over x is a graph that goes off to infinity around where x equals 0 and around where y equals 0. It's the same as the shadow. If you turn it 45 degrees, this would be the same as a shadow that a cylindrical lampshade casts on the wall when it's lit. Y equals absolute value of x is a V-shaped graph touching down to the origin, the sharp point here, and two straight lines otherwise. This absolute value of x is an example of what's called a piecewise defined function. It's defined here. Absolute value is defined as equaling to x for x at least 0, and the opposite of x for x less than 0. So in a piecewise defined function, you specify certain parts of the values of x and define what the function is on those special parts. So it's defined by pieces of the line. For example, y equals 1 if x is greater than 1. So that defines this part of the graph. Y equals x for x between -1 and 1. That defines this part of the graph. Y equals 2 if x is less than -1. That defines this part of the graph. As you can see, it has some mathematical inelegant parts. For example, here's a discontinuity where it makes a sudden jump at a specific point. It's defined at -1 here for -1, but it immediately jumps to positive for x even slightly less than -1. And here's a sharp point like here. And both discontinuities and corner points are considered inelegant in math. Okay, so that's that for that. I shall stop this for now.